This is the 2002 Mechanics Phase Response question number 2. There's a little bit of energy, a little bit of momentum, a little bit of rotational motion here. Actually put it all together. So first, in part A, we want to know what is the rotational inertia of all 4 tires. So this is one tire, and we want to figure out the rotational inertia of all 4 of the tires. Now each tire has a mass m/4 and a radius r. So let's just note here that capital M in the formula should be m/4 when we substitute, and L in the formula should be the radius r. And we have 4 tires, so we're going to take 4, 1/2 m L squared, and that's going to be 4 times 1/2 m/4 times r squared. And so what we're going to end up getting is a total rotational inertia of mr squared divided by 2. Now for part B, we want to know the speed of the cart when it reaches the bottom of the inclined plane. Here we are going to use energy considerations. So we will say mgh equals, now we have 2 energies to worry about. First is 1/2 mv squared. And actually, you know what? I want to be really careful about how I write this. So let me be super careful. So I'm going to say mass of the cart plus wheels gh equals 1/2 m of the cart plus wheels v squared plus 1/2 I of the wheels omega squared. So that's what I want to be careful of. So the mass of the cart is m, and the mass of the wheels are m/4. So this will be 2 little m gh equals 1/2 times 2 little m v squared plus 1/2 times, and it's all 4 of the wheels, so that'll be mr squared over 2 from part A. And omega squared, we're going to put v over little r squared right there. So we've got a little bit of simplification ahead of us. So we have 2mgh equals mv squared plus mv squared over 4 when everything cancels out. So we're going to end up getting 2mgh equals 5/4 mv squared. The little m's cancel finally. So we end up getting that the speed is 8/5 times the square root of gh. Actually, the square root of all of this, square root of 8/5 gh total. Excellent. Now, that's part B. For part C, it says, after rolling down the inclined plane and across the horizontal surface, the cart collides with a bumper of negligible mass, which has a certain spring constant, and we want to determine the distance the spring is compressed before the cart comes to rest. So what's interesting about this is we can assume complete and total energy conservation. So rather than doing anything elaborate, we'll assume that all of this gravitational energy gets converted into spring potential energy. So we're going to end up getting 4mgh over k under a square root equals this x maximum. Lastly, in part D, let's assume there's non-negligible mass. So the bumper is hit by the car and only compresses 90%. Well, momentum is conserved, and KE is dissipated in the collision. So that wraps up 2002 problem number 2.